will be of this form, where your degrees, these powers, the exponents, must be whole numbers. So who's the set of whole numbers? Right, there's our whole numbers. And then the coefficients, all these coefficients must be real numbers, right? So real numbers, anything, right? Fractions, decimals, irrational numbers like pi is even a real number, right? The only thing it can't be is like square root of -1, right? That's not a real number. So the coefficients just got to be a real number. And then we're going to classify these both by degree, and we'll actually do it by term as well on this. So the first thing, if you notice here, it's not written with the largest degree first. So I'm going to go ahead and put the largest one first, the -2x cubed. Then I'm going to put and I'm going to write it this way, 1/3 x squared. And then I'm going to put the 3x there. And now I'm going to look at it, and I'm going to say, okay, is this thing a polynomial? If so, then what's the degree? Are the degrees, I'm sorry, are all the exponents whole numbers? Well, first exponent's x to the third, right? 3. The next exponent's x squared, 2. The next exponent's x to the 1. It doesn't show the 1, but it's x to the 1, right? Are those all whole numbers? Okay. Are all these coefficients, are they real numbers? Yeah, so yes, this is a polynomial. So it's a polynomial of degree 3. Third degree, largest degree. Polynomial degree 3, that's also referred to as a cubic. It has a special name. If you're a third degree, you're a cubic. If you're a second degree, it's quadratic. If you're a first degree, you're linear. If you're a 0th degree, it'll be a constant, right? Let's also classify it by terms. I have 1 plus 2 plus a third term, right? The terms, number of terms separated by pluses or minuses. I have 3 terms. Polynomial with 3 terms. In other words, that's a trinomial. 3, tri. Right? If there was 2, I'd call it a binomial. If there's only 1 term, I'd call it a monomial. Anything above 3 terms, we don't care. We just say it's polynomial of 4 terms. Yeah, there's a name for it. We kind of just don't care after that, right? Because we never remember. So, all right. How about this one? Y or f of x equals square root of x minus 5. Well, square root of x, if I was to write that in exponential form, what would that be? X to the what? 1/2. X to the 1/2, right? That's the same thing, exactly. So that's the same thing as the square root of x. Now the question is that a whole number? Then you say, no. So is this a polynomial? Nope. Not a polynomial. And we end it right there. Let's do the next one. Let's write this as 5x to the -2. That's the same thing as 5 over x squared. I look at that -2. Is that a whole number? Remember, whole numbers are 0, 1, 2, 3, 4. Can I have a negative? No. It's not a polynomial. Not a polynomial again, right? How about this one? Now notice there's no x here. Let's write the x in. Anything to the 0 power is 1. This is just like 6 times 1. Is that a whole number? 0 power. 0. 0 whole number? Yes. 0, 1, 2, 3. Yep. This is a 0th degree polynomial because the leading coefficient is also a real number. That 6 is a real number. 0th degree polynomial. Well, 0th degree polynomial, y equals 6. That's just a constant. 0th degree is just a constant. How many terms do you have? Just one. There's just one term here. So 1 is a polynomial with one term. We call that a monomial. It's referred to as a monomial. Now this one's not written in the form to really look at it first, so what would you do first? Yeah, multiply it out, exactly. So what do you get? Good. Yep, so x squared plus 3x minus 10. All right, now let's look at it. Are the degrees all whole numbers? Yes. What's the degree then? It's polynomial. Yeah, second degree, which we call that what? We just talked about that last section. Quadratic, yeah. So it's a second degree quadratic. How many terms do I have? 3. Polynomial with 3 terms. We call that a trinomial. Okay. Now polynomials are special because they're smooth and they're continuous. They're smooth and continuous. Polynomial functions are smooth and they're continuous. Remember that, okay? Now, polynomial functions also have at most n minus 1 turning points. So like for this one, actually, let me go to let's say I had a third degree, like, I don't know, whatever it is, but I graphed it, and let's say it looks something like this. See how you have a relative max there and a relative min there? Those are called turning points, right? I changed from increasing to decreasing. And then I changed from decreasing to increasing. So I have 2 turning points right there. Does that make sense? So a polynomial function will have at most n minus 1 turning points. So if it's a third degree, it will have at most 3 minus 1, 2 turning points. If it's a 7th degree, it will have at most 6, 7 minus 1, 6 turning points, and so on, right? So it has at most that many turning points. So for this one, now it's kind of trying to trick you here, but what degree is this? It's a 5th degree, right? So it's a 5th degree, so it'll have at most how many turning points? 4, at most 4. Again, I don't know exactly what it looks like. Whoops. But this just shows you 1, 2, 3, 4 turning points. It'll have at most. Might have less, but no more than 4, right? At most n minus 1 turning points. So 5 minus 1, 4 at most turning points. At most 4 turning points. Okay. So let's talk about this. Now that we know they're smooth and continuous, let's talk about turning points first. If this is a third degree polynomial, I'm going to have at most how many turning points? 2. So it could be, who is it not then? It has not A. That's too many turning points, right? That has 1, 2, 3, 4 turning points. So there's no way it's A. Now these other ones look like they have some turning points. Which one would it be then? D. It is D. Okay, why is it not B? Good, it's not going to take good. So not continuous. Remember, these got to be smooth and continuous. Why is it not C? It's not smooth, right? That's a sharp point right there. So not smooth, exactly. Okay, good. Now we can actually, if we have zeros given, The number of zeros, I'm sorry, the degree that you have is how many zeros you will have. So if it's a third degree, you'll have 3 zeros. If it's a fifth degree, you'll have 5 zeros. Some of them might be repeated the same number, but that's how many you will have. Okay, and we'll talk about that fundamental theorem of algebra later in the course. But you can create a polynomial if you're given the zeros and a little bit of information. So notice here, first of all, I'm going to say it's a third degree, and sure enough, I have 3 zeros given. So I can create the function because now I know the factors. The factors are of the form x minus the first zero. Because if I was finding the x-intercepts, I would have to have the factor x plus 2 to give me negative 2 as my 0, right? And then x minus the next 0, and x minus the last 0. The last 0 was 2. Now, I left an a in front because I don't know what a is. A is any old number, and a will tell me which way it, if it's a second degree, if it opens up or down. If it's a third degree, a little bit different. We'll talk about that as well. But right now, we have to solve for a. Well, the only other information we're given is a point. Well, what could we do at that point to help us solve for a? That's our xy, exactly. Similar to with those quadratics, right? So that's my x and my y. Y is f of x. So that's our 6. X is negative 1. And now we're going to solve. So number 1, I used the zeros. And number 2, I used the point xy to solve for a. Step 2. Use the xy to solve for a. So number 1, use the zeros to create the function. You don't know what a is yet. And then use the point from there. Okay, let's finish this off. So it looks like a must be 2. So now we have it. We have our zeros. So we have this function, f of x equals a, x plus 2, x minus 0, x minus 2, and we have our a value. And we could multiply all that through if we wanted. All right, let me take that through. I got x squared plus 2x, and then let me multiply it by notice those are gone. Now I take the 2 through. Again, you don't have to, but we'll multiply it through so you can see it's a third degree there, right? It's a third degree polynomial. Now, if you are forming a third degree again, how many zeros should we have? Third degree, how many should we have? Supposed to have 3 zeros. How many do we have given here on this one? 2, right? So it's saying, okay, this third degree hits here at negative 3, and it hits here at 1. One of these must be a repeated 0. Let's make it the 1. So like I have some quadratic, and if it just touches, then that's an even multiplicity. It's a repeated 0. So my zeros, I'm going to make one that touches there. My zeros are negative 3 and 1, but I made it touch there, so I have another one. If it touches, I have an even amount of those zeros. If it crosses through, see how it crosses through at negative 3? Then I have an odd amount of zeros there. So I'm forcing this, to just touch. So I have 2 of those at least. I don't want it to be 4 of them. Again, I have an even amount. I can't make it be 4 of them because then I'd have a 5th degree polynomial. Does that make sense? I'm trying to create a 3rd degree polynomial. So let's use the zeros. Let's use the zeros to create the function. Don't know what a is yet, but I'm going to go x minus the first one, x minus the second one, x minus the third one. And then they did tell us, you know what? Let's just be lazy. Instead of giving it a point, let's just make the coefficient be what? 1. They're telling you just make a 1. Don't even have to do anything. So 1, x plus 3, x minus 1. There's 2 of those x minus 1. So here's our function. We don't need to multiply it out. We have our third degree polynomial that goes through those zeros, and it touches right there at 1. Right? So if you have even multiplicity, it's repeated an even amount, what's it going to do? Bless you. Touch. If you have an odd amount, like one of them, or 3 of them, or 5 of them, then it's going to cross through at that 0. Okay? So even amount of zeros of the same 0, right? Touches. So let's look at this one right here. Let's say you are finding the zeros on this. You're finding the zeros, and you're like, okay, I got 2x, x, x. I got 2 of these x minus 1s. And I've got 4 of these x plus 2s. So I said each of these x's equals 0, x equals 0, x equals 0, x equals 0. I got 3 of them, right? So how do you say that? You say x equals 0 with multiplicity 3. There's 3 of them. What's the 0? It's 0. There's 3 of them, so there's an odd amount. Does it cross or touch there? Crosses, yep. Let's do the next one. X minus 1 equals 0, x minus 1 equals 0. So x equals 1 with, how many of them are there? 2. X equals 1, multiplicity 2. Does it cross or touch right there? Touches, it's even. There's an even amount of those, right? And then the last one, x plus 2 equals 0. So x equals negative 2. How many of those did we have? 4, yeah. So negative 2, multiplicity 4. Does it cross or touch? Even amount. Touches, yeah. So I know I don't have the graph of this, but I do know quite a bit of information. At 0, it's going to cross through. Oops. Let me make that blue. At 0, it's going to cross through. So it's going to either increase or decrease through there. At 1, it's going to touch it either from the top or from the bottom. It's going to touch it, all right? And then finally, at negative 2, I'm also going to touch from the top or from the bottom, okay? So it could look like, and I'm going to give you a giveaway right here. If I was to multiply this whole thing out, I'd have 2x cubed times x. Like, how many x's do I have? Well, this ends up being 9. I don't know the rest of it, right? But this leading coefficient's positive. So it kind of behaves a little bit like x cubed, x to the 9th. It's an odd degree, leading coefficient 1. So it goes down to the left and up to the right. So this goes down to the left, up to the right. And I can kind of draw this a little bit. I need to plug in more points, but this is kind of what it's going to do. And I'll have at most 8 turning points. Now this one probably only has 1, 2, 3, 4 turning points, right? But it could have had up to 8 here. Does that make sense? So it's a 9th degree. So let's talk about that end behavior a little bit more. If your degree is even, if n is even, I always think about x squared as a great example. Bless you. X squared goes up to the left, up to the right, doesn't it? So anything like that has a positive leading coefficient, like 3x to the 8th minus 2x to the 7th, blah, blah, I don't know. Who cares about the rest? But it goes up to the left and it'll go up to the right, just like x squared does. Okay? So that's called end behavior. Now, if the leading coefficient's negative, like negative x squared, now it's going to go down to the left and down to the right. It's going to flip that over, right? Now, when it's odd, I think about x cubed. So if the degree of the polynomial is odd, again, I like to think about, x cubed. It'll go down to the left, up to the right. And if the leading coefficient's negative, it'll flip that around, up to the left, down to the right. Anytime the degree is odd and the leading coefficient's negative. Okay, so let's look at some here. It says let's go ahead and construct a polynomial given this graph here. First of all, it goes down to the left, up to the right. What's the degree, even or odd? Odd. Is it like the one on the left in red or the one on the right in red? Left. Good. So you know the leading coefficient. So the degree is odd and the leading coefficient is positive, right? So if once we construct this, if we screw that up, like that's one way to check it, right? When we construct this thing, you better have that. Well, I'm going to start with the zeros. How many zeros do I have? Yeah, I got 3 zeros. So -4, -1, and then 2, right? So here's my zeros. -4, -1, and 2. So I'm going to go ahead and start constructing this. I don't know what the a is, but I know my factors now. X minus the first one, x minus the next one, x minus the last one. Okay, give me another nice, pretty integer coordinate that I could use to solve for a. Good, 0, -3. Perfect, that y-intercept. So let's use, now that we've done the zeros part, let's use a point, a nice integer point, whoops, that's -3, to solve for a. So f of x equals, whoops, f of x is our y. So -3 is our y. A we don't know, but we're throwing the x in, which is 0, 0, 0. So -3 equals a. Oh my gosh. Whoops. That's not 0. That's -2. I'm sorry, you guys. -2. Sorry about that. -2, -2, -2. So our a ends up being -2/8 or -1/4. Now we can write the equation. F of x equals a, x plus 4, x plus 1, x minus 2. So I got -1/4, the rest of this. And that's it. There's our function. And if I multiplied all that out, you'd see, hey, I got a third degree. -1/4 x cubed is my first term, and the leading coefficient is negative. So it goes down to the left, up to the right. Sure enough, it does, right? And it's going to hit those zeros and everything. All right, appreciate you guys.